Good afternoon or morning or evening, depending on where you are. Thank you very much for joining this webinar. My name is Manish Parashar. I had the honor of chairing this committee, this ad hoc committee. I'm a faculty in computer science, currently at Rutgers University. What we're going to talk about today is a summary of the discussions as well as some recommendations that this committee had over the work that it did in the area of open science and reproducibility over the past few months. We started our work in early summer and have been working to the summer and part of this fall. And what you see here are some of the things that we discussed in some of our findings. Just before I move on, there's a URL which is a web page for this for the work of this committee. Currently, there isn't much content, but our goal is to put content in there as we go along. Next slide, please. So here's an outline of this webinar. I'll start off by giving a short introduction, and then we'll talk a little bit about sort of the driving focus of this work, which was the National Academy's report on reproducibility and replicability and its relevant recommendations. Then we'll talk a little bit about the different issues that we felt were related to ensuring reproducibility, and especially from a society's perspective. And we'll talk a little bit about these issues. We did a survey to see what is happening currently in IEEE Computer Society. And so we did a survey of conference organizers, workshop organizers, and journal EICs, and we'll summarize the results and then have a short set of recommendations and a next step. Next slide. This is going to be a tag team presentation. So as I said, I had a chance to work with a distinguished set of colleagues, and so we'll talk about the different aspects. So as I go along, I'll highlight who will be presenting the relevant sections. Next slides. So again, we started our efforts in early summer. This committee was charged by Leila to look at open science and reproducibility based on the recommendations of the National Academy's report titled Reproducibility and Replicability in Science. While it was focused on both open science and reproducibility, a lot of the discussions that we had really focused on the reproducibility aspect. And what we did was to look within the Computer Society, as well as peer societies and publishers, and see, relevant to the specific recommendations in this report, what was going on, what were the key issues, what were emerging best practices, if any, and then use those to come up with our recommendations. So the few key activities that we did over the past few months, we looked at the report and in detail and found out which of the many recommendations in that report were most relevant to this work. We took a survey among the different, as I mentioned, across the IEEE Computer Society. We started with the Computer Society and the journal, magazines, and conference chairs within the Computer Society. But then our goal is to have a broader survey, which we are currently planning. And then we identified what were the key issues that were related to ensuring reproducibility, and then did some deep dives where we spent a meeting or two focusing in on what the issues were, what was going on, and what should Computer Society and IEEE more broadly be doing. Next slide. As I mentioned, we had a very distinguished committee, and it was quite amazing when you can imagine how busy everyone on this committee is, and they were yet able to find time to engage in our discussions, and we had this every other week, and be able to present do the homework, look at what's going on. And so it was just an incredible honor and pleasure to work with this group. Next slide. So I'm going to now hand it over to Lorena. She, along with Victoria Stoughton, were two members of our committee who are also members of the committee that put this report together. And so it would be most appropriate for her to summarize the report and its relevant recommendations. Over to you, Lorena.
Thank you very much, Manish, for that introduction. Like you said, I was a member of this National Academy's study committee that delivered the consensus report, Reproducibility and Replicability in Science. This was the product of a long consensus study with 15 experts, including myself, and sponsored by the National Science Foundation, responding to congressional decree. And one of the important tasks that the committee had to complete was to canvas the usage of terminology and across different fields of science, and put forth definitions of these terms to move forward in consensus. And thus the committee offered these definitions. Reproducibility is obtaining consistent results using the same input data, computational steps, and code, and conditions of analysis. And this definition is synonymous with computational reproducibility. And it responds to the recognition that in the current business of science, really, computation is ubiquitous, and it's used in many aspects of the workflow of a scientist, from collecting data, analyzing data, collecting data from instruments and data acquisition, analyzing data, transforming that data through a pipeline, and producing results, sometimes from data-driven or simulation-based models. So with the penetration of computing, then it becomes much more important to emphasize transparency of the methods for the possibility of comparing results and assessing whether results are consistent across groups and labs. Replicability, in contrast, is a broader concern and refers to obtaining consistent results across different studies that must be aimed at answering the same scientific question, but may be using different methods for obtaining their own data. So two studies, especially in the empirical sciences, may be deemed to have replicated the findings if their results are consistent in within some level of uncertainty that should be reported. And thus replicability is a higher golden rule of establishing consistency and truth. But reproducibility is very relevant for the publishing ecosystem, because it requires a wider set of artifacts to be available. And let me see if, do I have another slide to talk about the results? I believe I do. I'm not controlling the slides. Thank you so much. There are recommendations in this report for many stakeholders, from the scientists themselves to publishers to editors, funders, and various members of the scientific world. And there's some key here that are highlighted. Recommendation 4.1 is addressed at researchers themselves, and highlights that they should convey clear, specific, and complete information about any computational methods and data products that support their published results, so that other researchers may be able to repeat the analysis with their artifacts. And of course, there's a recognition that in some situations, there should be allowance for privacy of data when it applies. For example, in situations of public health and or patient data, no? And then the next recommendation that is highlighted here, recommendation 6.1, talks about also for researchers how they should include very clear, specific, and complete description of how the results were reached. So also to aid in the reproducibility of those results. Recommendation 6.4 is targeting journals and calls on them to consider ways to ensure computational reproducibility for publications that make claims based on computations, which, as I said, is a very ubiquitous situation. There's hardly any scientific publication today that does not have some form of computational data analysis or statistical analysis. And of course, with understanding of the legal and ethical limitations that may apply. And recommendation 6.6 says that many stakeholders have a role to play in improving computational reproducibility and highlights educational institutions, professional societies as it applies to us here in this conversation, and researchers and funders. Recommendation 6.7 is targeting journals and scientific societies and says that they should disclose their policies relevant to achieving reproducibility and replicability. There's a recommendation for funders that is not highlighted here, but I do want to mention, which says that funders should consider adding reproducibility within their merit review criteria, and we see a movement towards that kind of consideration, which is a trend in science policy that we need to take into consideration. Thank you.
Thank you, Lorena. So now what we're going to do is to go through these 5 different key issues that we discussed. And as we go along, I'll call on the lead, the individual who on the committee who led the discussion to present them. So we'll start off. Next slide, please. We'll start off with roles and responsibility, and over to you, Mike.
Thank you very much, Manish. Yeah. So next slide. Oh yeah. Never mind. Stay here. So I'm going to talk about a workshop that we're planning. That's meant to foster discussion among all stakeholders, eventually to improve the trustworthiness of computational scientific results. There's a strong desire, of course, it's a noble thing to have trustworthy results. At the same time, realizing these improvements requires a broad community conversation about the roles and responsibilities, authority, accountability. One of the policies that Lorena mentioned, 6.6, talks about that there are many stakeholders who have a role, including universities, professional science societies, and so on. But understanding those roles can be very difficult. I've been involved in reproducibility efforts for a very long time, often within the context of Association for Computing Machinery work. Efforts, and I've seen repeatedly this pattern that individual teams will push forward and try to make their piece work right, but then there's not a corresponding engagement with other stakeholders of the community. And so I think to make community-wide progress, we have to be able to have discussions about, articulate the roles and responsibilities, so that as a community we can signal to each other what we can provide, what we need, and then be able to then make kind of qualitative across the board improvements. So next slide, please. This table is notional, but it's meant to evoke the sense that there are these kinds of activities down the left column, establishing quality requirements, transparency tools and processes, and so on. And then across the top are the stakeholders, of people who can either need them or provide them, or can incentivize them or give a reward for doing good work. And so the conversation that we'd like to have in this workshop is around how do we fill out these boxes. Next slide, please. just to build content for this, because I think there's a lot of latent understanding and awareness and desire to do the right thing, is to create a set of white papers and to incentivize or provoke kind of the right way of thinking, or a right way of thinking, is to provide kind of these template patterns for how people can write content and contribute to the workshop. Next, please. And then again, this is just a pattern, not meant to be restrictive, but to give a sense of, suppose that we want something, robust careers for research software engineers, and then given a condition, say a project ends, what happens? What we want to happen is that this research software engineer continues to be employed without fear of losing a job. And in a lot of institutions, in my experience, that's not the case right now. So how can we fix that? Next, please. And also, again, in my experience, there are a lot of what we call sometimes anti-patterns, or patterns that are not what we want to see. And often this results from not sufficiently addressing the challenges or providing the right context for people to do the right work. And so we want to try to address some of these anti-patterns in the conversation. Next slide, please. And so this is just a summary. We are developing a lot of tools and processes and policies, but they're often not done sufficiently in a bigger context so that we know about each other's efforts and can assist each other in elevating all the activities that have to occur for trustworthy computational science results to be a real thing across the board. Thank you.
Thank you, Mike. The next issue that we discussed was aspects related to providing infrastructure, workflows, and logistics support to really support reproducibility. And I'll turn it over to Jerry Grenier.
Thank you, Manish, and good day, everyone, wherever you are in the world. It's my pleasure to be here today, and I want to thank Manish for leading this effort over the past 6 months. So I'll talk a bit about infrastructure, workflows, and logistics. As many of you who know me, I'm involved in the publishing operations and publishing technologies IEEE staff in Piscataway. So when I talk about workflows, it includes the simple submission or collection of artifacts and data from the authors, review of those artifacts and data, providing access to those artifacts and data, and archiving that. And I'm happy to say that working with Manish and transactions on parallel distributed systems, we have in place a workflow that, albeit a rather manual one, we are successfully acquiring software artifacts, data artifacts, reviewing those successfully, providing access through IEEE Explore, and archiving a link to those via the Crossref DOI. That being said, any workflow solutions that we achieve in the publishing operations at IEEE requires a partnership with the research institutions, with the authors and their research institutions, and publishers during the publishing process. So when I list publishers, I refer to the different standardization efforts that are occurring across the publishing industry, and IEEE is very active in a number of industry associations in setting standards. And indeed, we just finished and will have shortly published a paper on reproducibility badging definitions. So this is not a single purpose, or rather a single role player responsibility here. It's the research institutions working together with the publishers is key to the success of reproducibility. Next slide, please. So I'm going to just harken back to some words from the NASEM report that Lorena reported on. And again, it supports my previous slide. Publishers, librarians, research communities, funders, other stakeholders must begin to coordinate and develop broader metadata to accommodate new objects, including data flow, data code, and workflows. And indeed, we have done that. IEEE has, and one of our vendors, CodeOcean and Crossref, we've developed a model for submission of software artifacts, for example, to Crossref. So the synergies are there between the different stakeholders. And in this other quote from the NASEM report, in the near term, before infrastructure is developed, publishers must be ready to host and serve artifacts from their own sites if necessary. And indeed, that's the state that IEEE is at right now. Before this larger infrastructure that NASEM refers to is built, IEEE, I think, is positioned well. They're positioned better, actually, than the commercial publishers. This requires, of course, investment. And commercial publishers, as we know, sometimes look at the return on investment before anything else. And I think that IEEE, given its mission, can play a key role in developing not only our own infrastructure, but working with the larger infrastructure, working with governments, funding agencies to see this realized. Next slide, please. So again, just a little more detail in my prior slides. So review of artifacts. The collection includes reviewing and recognition of review. So I've mentioned both. We're reviewing artifacts. We've got a badging system now in place. New badge designs are on the horizon. The definitions are completed. IEEE Explore design staff has worked with some iconography for artifact submission, artifact review, reproducibility, replicability, and we're putting them before user testing as I speak. We're identifying acceptable repositories. Subscription model, as you most know, we have IEEE Dataport to accept data. The commercial freemium models, IEEE actively working with CodeOcean as well as Figshare. The not-for-profits, Zenodo, Dryad, as well as select institutional repositories. So again, I think the distributed model can work, and it behooves IEEE to work with not one, but many different repositories and vendors who can help us accomplish the reproducibility tasks. And again, the metadata standards, as I mentioned earlier, that's descriptioning, including license information in the metadata, and then the persistent DOI. And DOI is fairly, I think, standard now for lots of code deposits, certainly within Dataport, certainly within IEEE Explore, and certainly within CodeOcean and Figshare, Zenodo, and Dryad. So DOI has taken hold. It's been in our community now for 20 years, and is the worldwide leader, I think, in the DOI. The DOI is a standard, yet Crossref is a provider of services around the DOI, and that's the leg up that Crossref has, is that it's a strong organization supported by libraries as well as publishers. Next slide, please. I think we now move on to incentives and norms with Lorena.
Right. Back to you, Lorena.
Thanks very much. If we could advance to the next slide. Thank you so much. And yes, in considering incentives and norms, it turns out that social epistemologists of science have been thinking about these things and writing about these things for quite a while. And there's substantial literature studying us scientists in our habits. And the so-called Mertonian norms that social epistemologists of science talk about include things like universalism, the idea that the validity of a scientific finding does not rest on who is making it, for example, but they also include norms about communal sharing, the idea that the findings of science are common property to the scientific community. And so those exist, in fact, for a long time in the tradition of science. And this is in the context of norms, that is the idea of an ethical approach. But when we talk about incentives, we usually, epistemologists of science, classify that as the economic approach, and raising concern for reproducibility and open science via incentives applies there. Things like badges, as we've been talking about, funding increases for activities that promote reproducibility, or things like reproducibility and replication awards, which is something that is now being done in many conferences. Have just recently been adopting these kinds of activities. And usually we concentrate on these purely economic incentives, but they are insufficient. They really cannot explain all of the trust-based scientific practices we have. For example, peer review and collaboration are practices that rely on some default trust that we place on each other as researchers. And this is where these norms come about, the Mertonian norms of communality, and these act in concert with economic incentives. Next slide. And what is the difference? When we talk about norms, the model there is social norms. And we can think about social norms as things that require normative expectations, which means that a large subset of the community expects conformity with those norms. For example, if you think about sharing food in some context of a social gathering in some culture, you can understand, when something is expected by a large group. And social norms do play a role, but if you think about these Mertonian norms that include sharing of scientific findings broadly across the community, they're not strictly social norms in the sense that the normative expectation isn't really required. And that is that because scientists are sensitive to credit incentives. And so there's this complex interrelation of both the economic and ethical factors. And here I picked up a very good quote from this work in the philosophy of science that highlights the sensitivity of scientists to credit. And he says that give sufficient credit for whatever one would like to see shared, and scientists will indeed start sharing it. So ethical factors do play a role, ethical meaning normative factors, but a combination of incentives giving credit through publication, citation, speaking invitations, certificates, supplementary funds, and perhaps in the context of computational work, we've talked about allocations of computing time that is targeting reproducibility efforts, for example. So one needs to be thinking of an ecosystem of both incentives and cultural norms. For example, when the NIH released in October 2020 the new policy coming soon on data management, they say that they aim to shift the culture of research to make data sharing commonplace and unexceptional. When they say that, they refer to making it an expected behavior. And yes, that's the end of my topic. Thank you.
Thank you again, Lorena. Next, we'll talk about the economic dimensions or issues, and over to you, Stefano.
Thank you very much, Manish, and good evening or morning or afternoon, depending on where you are. So the economics. I mean, we are in an association which is a non-profit, but this does not mean that there is not economics issue to consider, both for the association and in general. When we propose principles, we better find principles that are economically sustainable. It's difficult to justify maintaining an infrastructure without funding, and this has been this is a discussion that has been going on, ranging from open access models for publications, and it comes up again to bite us for opening up data sets and sharing data sets. How does an association such as IEEE maintain repositories for dataset if we need to? And one possibility is to use data processing charges, similar to the supplemental pages charges that are already required for journal authors in certain conditions, which of course it's like the simple model, right? You get the author that is depositing also data or depositing code, setting up a space for them. You charge them for that, and this is a possibility. But we all know, I suppose that most of the people connected right now are scientists or work in academia, because that's probably the interested parties for this discussion, not our peers from the industry maybe. As we all know, grants already hardly cover the cost for publication, and they don't even start to consider the cost for opening up access to data. There's also the possibility of creating data journals. For instance, Elsevier has this journal that's called Data in Brief, that basically allows you to submit a short paper describing data set and some insights about it and the data set, and you pay for publishing the article with the usual paid charges, and that covers the cost of publishing the data. You get in return, and speaking of the incentives, you get in return an additional publication that may or may not count for something in your states or institution use of bibliometrics, but that's a small incentive. There's also, as it has been pointed out, infrastructure that is free or almost free, and in some cases this is supported by institutions such as Zenodo, for instance. So if there is a free infrastructure, what are the possible incentives for an author to pay to do this? And in turn, what are the incentives for the IEEE to offer something where there is competition that is already free at a cost? There's also the fact that, which is not secondary, that in fact most of us publish multiple papers that use the same data set, not even from the same authors. You may reuse the data set of other authors. Actually, that's one of the reasons why we want to make data sets available for everyone in the first place. And what happens when that paper is published? Because if the publication mechanism is tied with the mechanism for giving access to the data, then when you have another paper, maybe from a different publisher that covers the same data set, you need to have ways to link this data to the paper. And maybe that's where the usefulness of our effort as an association lies, not in creating something new, but rather in finding ways to cite data and link data to papers that are bibliographically sound and resilient. That could be a contribution that IEEE could make. And maybe we could do this in the form of a standards initiative for creating metadata or ways to link across different data sets. much in the way that DOI has become a standard for describing the digital objects, we may have a standard for describing access to data. And this is also because, to be honest, it's very, I mean, the Institute has had some experiences in building infrastructure. It's kind of hard. It's not exactly what IEEE is built for. So maybe we need to use something that instead we have been good at, which is managing the references and managing the bibliographic consistency. That's something that we may play a role in. Also, there is an issue that we have touched briefly, but this is probably part of the larger issue. How do we integrate these elements of reproducibility within the review workflow? Because if you review a paper and then when the paper is published, put the data available, well, in fact, you would need to have the data available already for the reviewers. That's one of the reasons to create an open way to share data and artifacts. And if you tie the availability of data to the availability of the final paper, you basically kind of create a catch-22 situation. In the next slide, there's also the dual part of the interest for the authors. We have already mentioned that data journal can create interest because you have an additional citable item. There's the entire fact that articles are, you know, we are still in the evolution which brings us from articles printed on paper to articles as digital objects. But once we fully transform articles as digital objects, and this is an enormous transformation that maybe is going to wash away the concept of having separate journals or the concept of having differences between proceedings and journals, because the article is just a digital object. And then you may want to cross-link it in a different way. Then maybe if the article is really a digital object, a living digital object, you may have different ways to construct them. For instance, we discussed and envisioned within the committee, it's not difficult to imagine, having graphs in the paper that are automatically produced from the data sets as a way to create a reproducibility for the experiments. You don't have a graph that has been sealed, but you go on this graph and you can automatically bring up the environment with the data to play with the data yourself. And this would be surely an evolution that would make it interesting for authors to actually contribute the data. There's also the mention that PLOS and Wiley and also others, I'm sure, already have initiatives in this direction. So even if we are a non-profit, they are our competition or one of the parameters that we benchmark ourselves on. And so we probably need to figure out the best way to remain on the same edge, remain competitive as one of the leading publishers in our area. I think that this is all from the generating interest. There is the portion, the last point is actually one of the points that are probably going to create issues here, which is the fact that when you publish the data, of course you create interest, but this could also be negative interest because someone may demonstrate some faults in what you do, which is kind of the point because we are scientists, but we all know that that's something that we are all, you know, in some way afraid of as well. So it's a legitimate concern that we need as a community to go over. Okay, and with that I'm done, and I hand over back to Mahesh.
Thank you, Stefano. I appreciate that. So the final issue that we discussed was sustainability, and I'll call on Niels Ashkenbrook to summarize that. Over to you, Niels.
Okay, thank you. Hello, everyone. I hope you can hear me. And yeah, so we were talking about sustainability, and the idea was to discuss in detail what needs to be done that the things we want to reproduce are sustainable. We already heard about replicability, reproducibility, and yeah, in the end, this means that we want to have the stuff we make available to be reusable. Next click, please. And for the part of software, there's some work already done, and we all know, I think, the acronym FAIR for findable, accessible, interoperable, and reusable. And we want this for software. But so in many areas of computer science, we produce software and we upload it to GitHub or somewhere else. But this is not the thing we need for sustainable reproducibility. Next slide, please. So the question is, is reproducibility just a matter of availability? Of course, availability is important, but it's more. So what makes an experiment or a result really reproducible? We have to have the code available. Maybe we need to make the binary public available. Maybe the execution scripts and parameter settings, maybe even the raw results that should be public available. However, there are so many other things we need to consider, which in the end may result in failing to reproduce the results. And we don't, of course, want this for experiments that have been done properly, right? So we want to, in the end, we want that the results are reproduced and replicated. So we also have to consider of the hardware, the operating systems, libraries, random number generators, etc., etc. Of course, there's a different state of art in performance evaluation in different areas of the computer science. And also the impact of the hardware is different. So if you think of an area where we have mobile devices and then you want to reproduce results with new devices, yeah, you want to do this, but then you have different chips and all these issues. Of course, there's also the impact of operating systems. If you want to reproduce a result with a Linux version that's 5 years old, it's sometimes even hard to get the right libraries and system even installing it. And then you have the impact of random number generators and so on and so on. Next slide, please. So there are some solutions and also challenges that are discussed on the technical level. So as solutions, there's some people proposing to have everything in a container and then publish the container where everything is installed. And maybe you can also do it in a virtualized environment and publish the virtual box or whatever kind of virtual image you have. And but this depends on the area of computer science you're working in, right? And actually it will also depend on the experiment you're doing. For example, if you look at computer networking, which is quite broad as in other areas, some people use simulation, others use prototyping, some people even do real measurements, and depending on what you do, you may be even doing human factor experiments. So it's pretty broad, and so it's kind of challenging. And in the end, it all depends on the area of computer science. So it's quite hard to have one solution that fits all across all the different technical areas that we are covering within computer science and also within the computer society. And that brings us to the next point, I think, where we try to survey it a bit. So that's it from my side. Thanks.
Thank you, Niels. I appreciate that. So as we were getting towards halfway through our study, we realized that it'd be good to figure out what people are actually doing and what are the issues they're facing. So we worked with the IEEE Strategic Research Group and in particular Josephine Russo, who worked with us and really in a very short time put together a survey that went out to conference chairs, workshop chairs, and journal and magazine EICs. And so I'll call on Jerry to, at a very high level, summarize the outcomes of this survey.
Thank you, Manish. Could you please advance? Thank you. So we surveyed, the survey went out to 422 IEEE conference organizers and journal and magazine editors. The conference organizers were provided by the Computer Society through Robert Baldwin. So it wasn't a broad IEEE conference organizer set. It was specifically Computer Society folks. The journal and magazine editors, of course, were across all of the IEEE. We got a response rate of 31%. which I think was fairly good. Key findings. The story is this: 4 in 10 reported that they have policies in place or are planning to institute policies supporting computational reproducibility in the future. 6 in 10, or 60%, do not have any policies in place to support that. Of those 4, out of that 40%, 62% of those allow results to be submitted. 43% request system software details in the text of their articles. 44% allow raw data. 22% have a formal infrastructure in place for accepting and processing artifacts. And here's a surprising one for me. Most do not assign badges for artifact submission. Someone alluded to earlier about the recognition. I think it was Lorena. And I like to say that badges are can become a currency in one's publishing output, much like citations are. But the data coming back from the survey reported 13% use IEEE badges, 6% use ACM badges. 76% cited or recommended rather GitHub as a recommended repository for those artifacts. Going back to the badges for a minute, I mentioned earlier that IEEE had worked with an information standards organization to develop definitions of badges, and the ACM, who had their separate set of badges, has agreed to the new definitions and new badges so that we agree at least now to have some standardization across these two organizations, but also across the larger publishing community. So my key takeaway from this is that we're still pioneering, we're in the pioneering stage of reproducibility as part of our publishing process. And a more coordinated effort is required across all of the societies, working with the publishing operations groups in both the Computer Society and at Piscataway to publicize a program and develop the review capabilities, the storage capabilities, and the access capabilities for reproducible research, artifacts, and data. So we have some place to go. And I think 2021 can be the year we can build this coordinated effort. I might describe the current effort as a best effort. There have been little projects here and there. Manish, his project with TPDS being the most prominent. But I think it's time for us to put together well, we'll hear that in our next steps. I'll leave that to Manish to go over the next steps. So thank you.
I think you have one more slide. I don't know if, oh yeah, I think you're somewhere.
Oh yeah, I'm sorry. Yeah, so there's some random comments from taken from the survey. Badges and other forms of recognition might help. There's no defined process. Each author has the option to link to IEEE Dataport and upload their data set. We see that as pretty as fairly common. Authors can submit their open science materials through a shared GitHub activity. We don't have a clear process and have not seen a strong need. That surprised me. It's not a common practice, still in the learning phase. I think what this all adds up to is that things are pretty much, people, a certain cohort has the right intention in mind, but I think the staff within the IEEE publishing operations need to coordinate the efforts and help the editors and the authors become more frequent participants in this effort.
Thank you, Jerry. So just one final slide with some recommendations and next steps. Right. So I'd like to call on my colleagues on the committee to chime in as I'm talking about these, because this was something that we built collectively, and I'm sure they have thoughts and I might miss something. So the overarching, I think, recommendation is that this is something that's urgent and it needs action, right? It's we cannot do things, as Jerry decided, in an ad hoc, best effort way. I think it needs a coordinated effort and an urgent and there's an urgency around it, right? So the key recommendations, I think, is to come up with a cross-cutting strategic and implementation plan that defines clear goals for the technical committee, conference, workshop organizers, journal EICs, magazine EICs, about what we're trying to achieve and how do we want to get there? What are the best practices, right? And I think this has to be done in a broad way, and it should be done across all of at least Computer Society, and I would say across IEEE. Clearly, there are different needs that have to be managed, as you know, not all aspects of computer science require exactly the same approach. But I think building that effort and understanding what those needs are is important. I think the support infrastructure is very, very essential. Right? In the few efforts that we have seen, as the survey indicated, where people have tried to put these things together, the lack of infrastructure has been a key barrier, right? And doing this properly requires building the infrastructure for example, submitting the artifacts, code and data, and evaluating them. And how do we make sure that these different submissions are really integrated so you can evaluate them as a whole rather than bits and pieces? It's the effort on not only the editors, but the reviewers. How can they see the entire picture and then evaluate it as a whole? How do you create the workflow, right, within Scholar One or whatever the system is being used, where we can take it from submission to publication in an integrated manner, getting things reviewed, getting feedback to the authors, getting revisions, and be able to do this within a single unified workflow. As Jerry mentioned, we've been doing this in a rather manual way, so we do understand what the process should look like, at least for one or for the journal that I've been looking at. However, I think creating that structure to support it, I think, is important. And then finally, we need to start standardizing, and Jerry mentioned the NISO effort that some of us are part of, right? But then integrating that badges into the workflow. And again, something we have done effectively in an ad hoc manner, but it can be integrated. So clearly having the entire support infrastructure to do this in an effective way is essential. I think communication around this is very important. I think once we have defined what the strategic approach is, building a communication plan so that the expectation from authors, from the reviewers, from the community is well understood. And we can do this in a transparent, fair, and uniform way across all the different aspects, publications, conferences. And finally, this has to be done in coordination with other societies, organizers, and stakeholders. I think the NISO effort, again, that Jerry mentioned, is a very good example for such coordination. But I think this is a bigger problem than just IEEE, a bigger issue. And I think doing this in a coordinated way is very, very important. And in terms of next step, I think this ad hoc committee, I think, scratch the surface, spend some time looking at the issues and understanding what's going on. But I think a dedicated effort is needed to be able to address this in a consistent and holistic way, and to build and implement recommendations. I'm going to pause here and see if my colleagues want to add anything that I might have missed.
Very nicely stated. Thank you, Manish.
Just restate the obvious too, Manish. And for those of us who, familiar with the IEEE structure, this will require an effort across both the technical activities, publications, and standards, at the board levels, I think. And I would, begin by recommending, at least, my association with PSPB is to perhaps, have, a larger IEEE committee with members from different boards serving as liaison on that committee.
Thank you. if there are no other comments, Stefano, were you going to say something? No. If there are no other comments from the committee, we might be able to take maybe 1 or 2 questions from the attendees. Now we have 3 minutes before the top of the hour. I'm putting you on the spot, Leila, but would you like to say anything?
Manish, it is Michaela. I'm sorry, I can turn on also my camera. Thank you, everybody, for this great presentation. I see that the team that have put together this presentation is international. And something that comes to my mind is the importance that this effort go beyond a single country. And luckily for some of us, we have institutions in our country like the National Science Foundation, NIH, who are listening and are very responsive. But to be successful, I feel there is the need for something more international, which is the reason why I applaud the fact that the society, ACM and IEEE, are promoting this initiative. And I stop here, but thank you so much for the presentation and the effort that you and your team have put together. Thank
you, Michaela. I couldn't agree with you more. Appreciate your comment.
So Manish, I have a quick question. I wrote it also. Is IEEE CS coordinating this activity with, say, ACM and AAAI? We are requested to submit the code and data for several conferences. It would be good to have a uniform platform. And then some people, some others have commented as well on that.
No, thank you, Bhavani. No, we are definitely coordinating with ACM. We were part of the NISO group that Jerry mentioned. I know Mike Heru, and among others, is very active in the ACM community. And so we try to, to the extent possible, coordinate and try to do things without reinventing the wheel or doing redundant effort. In terms of AAAI, I'm not that sure. I don't think we have had explicit conversations with them, but I'll see if some of my colleagues have some comments there.
Because the reason I mentioned AAAI, Manish, is that it's also becoming major, not as much as IEEE and ACM for computing, but still it's there.
No, I agree, and especially given the prominence of AI ML today, right? I think this is great point, and we will reach out to them and see how we can explore that. Thank you.
Manish, this is Rowdy. If I could make a comment here, so you know, we have in the IEEE Standards Association launched IEEE SA Open platform for open source code, but that has a number of advantages, in my personal opinion, over things like CodeOcean and GitHub and GitLab and so forth. We're already in discussions with Dataport, and Salona Bonewald, the executive directors, here on the line, and I would invite you to coordinate as much as possible with us, since this is an internal IEEE product and offering, and it is, as was pointed out, free.
So I think that's great. Thank you for pointing it out, Robbie. This is really very timely because we are sort of struggling with an issue that came up. Again, this is as we are trying these pilots, we're discovering issues. For example, not all types of artifacts are compatible with our current solutions, and maybe something like what you mentioned might be the right solution, right? So thank you for that suggestion. Looks like we are over by a minute. Any final thoughts before we end this? If not, thank you very much. I hope this was useful. Again, I thank the committee members for the tremendous effort they did on top of everything else that they do. So I really appreciate it. And we hope to keep the conversation going and move this forward. I think this is really, as I said, scratching the surface. So thank you again for attending, and
thank you
have a good rest of the day.
Thank everybody. Also on behalf of the Computer Society, thanks for the committee and to the participants. Thanks a lot. It's great work. Thank you.
Thank you. Goodbye, everyone.
Bye.
Thank you.
Bye.